We're going to do lots of examples of adding and subtracting fractions because there can be some complicated things. It's definitely a little more difficult than multiplying and dividing. And each problem, sometimes has its own differences. So the steps though. Step 1 is factor denominators. Step 2 is find the least common denominator. And the least common denominator should have each factor in it from both fractions. And then finally, we multiply to get all the fractions to have that LCD. Fractions to have that same LCD. The least common denominator. All right, let's see if that structure helps us. So first step, factor. X plus 3 does not factor, but this is a difference of 2 squares. It's x minus 3 times x plus 3. So the least common denominator, I need each factor represented. Maybe represented is a good word. So in that case, the x plus 3 is there, but I also need that x minus 3. So the least common denominator is x minus 3 times x plus 3, which means we have to multiply the first fraction by x minus 3 on top and bottom, because that's what the first fraction is missing that the second fraction had in the bottom. I'm not even worried about the tops, right? These first 2 steps, I'm not even looking at the numerators. Now, we're multiplying both top and bottom, so we're finally incorporating the numerators. So after I multiply 1 times x minus 3, the top of this fraction is going to be just x minus 3. The bottom is that LCD, x minus 3 times x plus 3. Plus, we don't need to multiply the second fraction by anything. It already has that least common denominator. So the top's going to stay 6. And then the bottom is x minus 3 times x plus 3. All right, we got our common denominator. Now we add the tops. So that's final step, is add or subtract the numerators, depending on what it's asking us. Well, let's see. X, we definitely have an x. I'm going to keep my denominator factored. And the top's going to have an x, and then negative 3 plus 6 is plus 3. Oh, wait. Last thing we might need to do is simplify. These x plus 3's cancel. If everything on the top or the bottom cancels, what's left behind is a 1. And then x minus 3 is on the bottom, with this added restriction that x cannot equal negative 3, because that would make this 0. So that's last step. Sorry, I didn't give myself enough room for me to write these steps, but last step is simplify. All right, so we factored the denominators, found the least common denominator, multiplied this first fraction to make them match, added the numerators, because this was an add problem, and then at the end simplified. Let's do it again. First, no factoring needed, right? There's no squared, nothing to factor in the second fraction. But we need to have a least common denominator. I'm not loving that this x is negative, so yeah, this one's a little bit weird. I'm going to write this as negative 1 times x minus 3. Now, there are 2 different ways to do this. One is to multiply this first fraction by negative 1. What I'm going to do instead is move this negative up to the top. Let me show you what that means. So if I have 8 over negative 1 times x minus 3, the second fraction, that's the same as negative 8 over x minus 3. It's sort of like when we were canceling, when we flip the subtraction, we get this like -1 when we reduce. Same thing here. That 8 divided by -1 makes a -8 on the top. That's actually an easier way to go than to multiply the first fraction by -1. But both methods work. I'm going to go with this though. It's a little more sophisticated, let's say. So what I get is 6 over x minus 3, and then now plus a -8 over x minus 3. So by flipping the subtraction in this denominator, it makes the top negative. Yeah, let me write that out. So flipping the order of the subtraction in the denominator makes the numerator negative. The numerator negative. All right, well now that we have all that, what we get in the top is -2 and then over x minus 3. Definitely a little different on that one. All right, let's try one where it's sort of back to regular, just factor and find a common denominator. Now, I'm not factoring tops of fractions. I couldn't anyways. X squared plus 15 is prime. But even if it were factorable, I wouldn't bother. It's just the bottom. The denominator has a GCF of x, and then what's left is x minus 3. The second fraction has that x, but we're going to have to multiply by the x minus 3 to get them to match. So that's the least common denominator, is x times x minus 3. Now the top of the first fraction just stays x squared plus 15 minus, the bottom is now x times x minus 3, but multiplying this numerator involves FOIL. This is a full FOIL problem. I need to multiply it all out, or you can use box method. I might use a box method on this one. I'm feeling, it's been a while since I did box method. Let's do that. So I have x minus 5, x minus 3. We're multiplying it all out. I get x squared minus 3x minus 5x, then plus 15. When I combine the like terms in the middle, I get x squared minus 8x, and then plus 15. So the numerator needed FOIL because we are multiplying a binomial by another binomial. All right, so that was tricky enough. Now, what's also tricky is this minus sign needs to distribute to all 3 of these pieces. So it's going to flip all the signs. Negatives become positives, positive become negative. But I can put it all together now. So the bottom, keep it factored. The top, we multiply it out, combine like terms. So we get the x squared plus 15 minus x squared plus 8x, because a negative times a negative makes a positive, and then minus 15. Whew, are we done? Nope, we are not. But it simplifies really nicely. The x squareds cancel, plus 15 minus 15, that cancels. So what I'm left with is 8x on top, and it's a positive 8x, and on the bottom is x times x minus 3. Okay, now are we done? Nope, one more step. The x's also cancel here. Now, before, I couldn't just cross out like one x, but now that it's factored, this is 8 times x, now the x's cancel. I can't cancel them unless both x's are being multiplied by something else. So this is 8 over x minus 3, and we've canceled something with an x in it, so we have to put a domain restriction that x cannot equal 0. Whew. All right, that's final answer. That one was tough. All right, let's see what happens if they just randomly have a whole number. Okay, well, whole numbers in fraction problems, typically we want to make them fractions. So I'm going to write this as 2 over 1. That's the same as 2, but now it looks like a regular fraction subtraction problem. 1 isn't really adding anything to this party, it's just a placeholder. So the least common denominator is x plus 3. So I need to multiply the first fraction by x plus 3 on the top and the bottom. All right, let's do it. So first fraction just stays x plus 2 over x minus, or x plus 3. Yeah, I think I'm gonna go ahead and write it out like it's one piece already, because I want to view this negative as being with the 2. Because when I'm distributing, I need to distribute -2 to both of these pieces. All right, remember, if there's a minus sign that goes with the top number, so it needs to be -2 times x, -2 times 3. So in that case, x plus 3 is that common denominator. The top is going to be x plus 2 minus 2x minus 6. Right? That 3, once I multiply by -2, it becomes a -6. And now we can combine like terms. X plus 3 is still on the bottom. X minus 2x is -x. 2 minus 6 is -4. If you want, you can factor out a negative out of the top, but it's not going to cancel with anything in the bottom, so I'm not even worried about it. I think that's a lovely answer. Done. All right, last two on this page. First step, right? Remember the steps are at the top. Factor the denominators. This one, we're looking for two numbers that multiply to 1 and add to -2. So that's -1 and -1. They multiply to a +1, but add to -2. So what that means, and you know, another thing that might help some of us, because it's this negative in the middle, you can always make it plus and then just move the negative right up to the top right away. Right? Instead of minus this fraction, I can make it plus and just move the negative to the top. You can do that on any of these problems. The negative applies to the top numbers. So the bottom is just going to be x minus 1 times x minus 1. Well, let's look. What's the first fraction missing? Well, it's missing one of the x minus 1s. So we're going to need to multiply the top by x minus 1 on top and bottom. So that makes the bottom x minus 1 times x minus 1, keep it factored. And the top, I just multiply the 7, so it's 7x minus 7. Hopefully we see that. The -3 is now on top. So now I just add. We keep that common denominator, x minus 1 times x minus 1. And at the end, maybe I'll write it as squared, but let's first, maybe it's gonna cancel or something. So let's first simplify the top. Combining like terms, 7x is just 7x, -7 and -3 make a -10. So the nothing cancels because I can't factor the top. You can only cancel if you factor. So we can just write it as 7x minus 10 over x minus 1 quantity squared. Ooh, that one was actually not as bad as some of the other ones. All right, last one. This one, we need to factor both denominators. First one has a GCF of 4. And after you factor out the 4, it's x plus 4. The second fraction has a GCF of x. After you factor out the x, what's left is x plus 4. So in this problem, our least common denominator, I need a 4, I need an x, and then one of the x plus 4s. So 4x parentheses x plus 4 is what we need both denominators to become. Now what the first fraction is missing is an x. So we're going to have to multiply, I'm going to do it up here, multiply the first fraction by x on the top and bottom. All right, so it's the same fraction. I factored the denominator, and now we've multiplied by x. I'm moving this negative up with the 2, so I'm making it plus -2 on top. And what this fraction is missing from the denominator is that 4. So I need to multiply by 4. And then the denominator would be 4x times x plus 4. So I moved the negative up to the 2 and made it just a plus. And then now we can combine these into one big fraction with the common denominator of 4x times x plus 4. And then I need to multiply out the tops. The numerators, x squared plus 2x minus 8. Now that looks like something I should be able to factor. So we need to find two numbers that multiply to -8 and add to 2. That's sounding like 4 and -2. All right, those would multiply to -8, add to 2. So the top's going to be x plus 4 times x minus 2. And the bottom 4x times x plus 4. Oh, look, the x plus 4's go away. So final answer is x minus 2 just over 4x with the added restriction that x cannot equal -4 because that would make the original problem have a 0 in the denominator because that's the factor we canceled.